Okay, so Advent of Code Day 2. Finally we're getting around to this. Maybe have a quick peek at the leaderboard, where we have no chances of getting into because I start too late, but let's peek at our private leaderboard here. Ooh, Lucas, you're beating me. I'm gonna have to start writing some code for Day 2. Okay, let's see what they want us to do. My flight departs in a few days. The toboggan, what is that? Do we need that? Let's have a look. See, a toboggan is a sled. Okay, it's still Christmassy. Can't log in. Password database is corrupted. Some of the passwords wouldn't have been allowed. Debug the problem created a list of passwords according to the corrupted database and their corporate policy, and the policy is here. Each line gives the password policy and then the password. The password policy indicates the lowest and highest number of times a given letter must appear for the password to be valid. So we need 1 to 3 A's in here, so that's valid, and 1 to 3 B's and it's invalid, and 2 to 9 C's and 1 to 3. That's valid, invalid, valid. 2 passwords are valid. Yeah. How many passwords are valid according to their policies? Okay, well, that's going to be fun. Best we log on. I did make some post-video changes to the code for day 1 and did some templating that you will see. I made a little template because I think we're going to be reusing opening and reading files and a little header as well. So we are going to start with day 1, part 1. Day 2, part 1, and we're just gonna copy our skeleton in. At least then we have that one. Day 2, part 1, and we're probably gonna have to open that file as well. So we're gonna say copy that file, yeah, and we're gonna do an input for day 2. Then we better create that file and then first fill it up with this piece of example code and to see if we can get this algorithm going. So I'm going to be very easy for this. I'm just going to copy this file to copy this here, copy and paste. Make that day 2 input. Yeah, use the same things. Let's see. Yeah, now we have all that data there. So I'm just going to delete this. Let's do our vi slash, where are we? Did that cancel out on us? That's a pity. Okay, we have to set that up first so we have our console working. Right, so I've restarted that little terminal. 10.1.1.2. Let's log in here, clear, and we do a vi slash tmp slash d2 in. That will do. I'm gonna take this example just to work with from the start, and then we'll do the rest later. Paste that in, and then over here on the mainframe side in TSO we're gonna say copy slash tmp slash d2 in. Right, and then at least we have our input file that looks the same. Keep forgetting we're on day 2. This time we're of course not reading into entries, but let's see what they call that over here. Naming things is always the biggest issue. List. Right, we'll just call that the list. So once we do this, we should get all our entries in that stem variable called list, and we can iterate through them, and this is where I think REXX really shines. So we can start parsing that input line very easily. So what we're basically trying to do is iterate over all the list entries, and we probably want to start by saying valid equals 0. That's probably what we want. So we start with 0 valid passwords, and then we want to do something like I don't know, I probably just want to call a function, right? A little function that will parse the input line and count the number of occurrences of the character, and then do that, and then see if it's valid or not. That should be good. So we're going to say if valid parse, and we're going to give that, what does that need? Just the whole list, right? List.I. This needs an equal sign that we spotted. If it's valid, bong bong, then valids equals valids plus 1. Say valid passwords valids. Exit our code, write our function, valid pass, parse our arguments, which is the list, which is just a string, a line of text, right? We're going to give it a line of text. That sounds good. And now we're going to parse that line, and we know what it looks like because it has a minimum value, then a hyphen, then a maximum value, then a space, then the character, how many times it can occur, then a colon and a space, and then followed by the password. So that should break up that string all in one go. It's kind of like a regular expression, but it isn't. And just to see if it works, we're gonna say let's do a say min max character in character in password, right? And this of course needs to return something because it doesn't have true or false. So if valid pass equals 1, I'm just gonna return 1 here. So now it should at least print some stuff to see if we're parsing this correctly, and it should reply valid passwords 3 because every single line is determined to be valid. I think at least that's what I expect. Yeah, so we need 1 to 3 A's in ABCD, 1 to 3 B's, and yeah, that works like we intended it to do. Good. On with the show. Of course, we don't want this anymore. Probably. No, we don't. And we don't want this. Now we need to iterate over all the characters in the password and see if it's in between those values. And if it is, it's valid, and otherwise it is not valid. So we are probably going to have to loop on that thing. So we need another do loop. Do jj, why not, equals 1 to the length. Yeah, probably the length, right? The length of our password. And then we can substring all that stuff out. So we might want to strip our password as well, so we don't take all those blanks as well. Right, so that should strip it, I think. It chops off all the blank spaces at the end. And then we can say we need to do the count, right? Count equals 0 if substring of strip. Do we need to do the strip again? No. Password from position jj with the length of 1, if that is equal to the character that we need, then count equals count plus 1. That's basically it. And then if our count is greater than or equal to the minimum amount we need, and the count is less than or equal to the maximum amount we need, then return 1, meaning it's a valid password, else return 0. I think that looks promising. So let's see what the example tells us the answer should be. In the above example, 2 passwords are valid. Well, bah! See? Valid pass doesn't run. We have some function errors. If valid passed, valid pass, does that delete those things there? That returns 1. Why doesn't this work? Why doesn't this work? Don't know. Don't know. Valid pass. Valid pass. What did we do wrong? Let's run it again and reread the error message. How does that look? If substr password line 36, routine not found. Oh, it's my... Maybe we should read more decently. It's my standard typo where REXX doesn't have a susbtr function, but it does have a substring function. You should have seen that on the color. That is hateful. Execute. Valid passwords equals 2. Well, that makes me feel confident. Let's get our puzzle input. Whoa, that's a big list. That's a big list of things. So I'm going to copy that in, do the same trick, temp d2 in, get rid of these ones, paste that thing in. This is just the handiest way of doing so. Get rid of that last blank line, go to our input file, get rid of our example stuff, and copy temp d2 in. I don't know what that XC at the start is. Did I miscopy something? 34G. I think it miscopied, right? At least it looks like we did a miscopy. So always pay attention to your inputs. D2 in. That ain't right. rm/tmp/d2 in, vi/tmp/d2 in. Try it again. Insert, paste. We get the blank line at the end, probably. Yeah, get rid of that one. Do it again. So delete all these lines. Let's retrieve the previous, that one. 47Z, that looks right. And it's a total of 1,000 passwords and their rules. Some real funky passwords at that. So, if all goes well, we could submit this, execute this. And we find 396 valid passwords. Well, that is correct. Okay, time to tackle part 2. Time to tackle part 2. What happened and what do we need to do? Oh, we have the wrong password policy rules from his other job down the street. So we have the same input file, but it means something different. It now says this is the first character, that is the second character, and right. So now it means that the A needs to be at position 1 or 3, or the B needs to be at position 1 or 3, but not both, and the C needs to be at 2 or 9, but not both. So basically we could add that to our existing one, or just copy it and change the rules. I think we're going to copy it. Day 2 part 2, copy day 2 part 1. So all the constructs stay the same, just this is different. This all stays the same, but We don't need this anymore. We definitely don't need this anymore. And position 1 and position 2, because they now mean different things. Again, naming things. So we need to see if those things are the same in the password, right? So we can say something like if, it's going to be a very long line, so I just coded a bit verbose to see what we're doing. So we're going to say sum equals 0 if substring C substring of password at position P1 for 1 equals the character, then sum equals sum plus 1. Do some lazy tricks. Repeat that line. If the substring of the password on position 1 is the character, then the sum is also increased by 1, and only if 1 is right. So if the sum, only 1 is good, so we can just say return sum. Now 1 is the only correct answer, and we still check for 1 over here. Well, this still shouldn't be, it looks too easy in a way. Let's review. Substring of the password in position 1 is the character. I think it's just good. Execute. 428 correct passwords. Well, that's good. So that's day 2 finished again. Let's see if I've beaten Luke in this, which I probably didn't, seeing as he finished it earlier. Oh, I am so lagging behind. Okay, that's it. Done. Cool. Up for the next ones.